Hello and welcome to 5-Minute Math. Today we are looking at the Algebra 1 concept of writing exponential functions. This is standard A.9C in the great state of Texas, and we are using item number 9 off the 2019 released STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we have got this exponential function graphed here. We need to find the best equation for it. Well, how do we do that? Well, let's look at our standard form to begin with. Y equals a times b to the x. That's our standard form for the exponential function. We know several things about these terms. So your a is going to be, if we're dealing with compound interest and money investment, is going to be your principal. You can also just call it your starting or your initial amount. Or if we're dealing with a graph like we are in this problem, we can actually call it our y-intercept. Now, why could we call it our y-intercept? Well, our y-intercept is when the graph crosses the y-axis. That means your x equals 0. Well, look at the initial equation. What happens if we make our x equal 0? That would be a times b to the 0. B to the 0, anything to the 0 is just 1, which means it's just a times 1, or just a. So when x equals 0, y equals a. So that's very helpful to know. B is going to be your rate. It's going to be your growth rate. If it's increasing, it's going to be your decay rate if it is decreasing. And then your x is going to be your steps. Typically, it's going to be your time period. It might be days, weeks, months, but we don't have any context for this graph, so we'll just call it steps. So we can actually get this information here. Knowing that a is your y-intercept, that's going to be helpful. So we know that. So we can say g of x equals that a is going to be 6, which we have that for all of these right here. What we need is the rate, and that's the hard part. We've got a few different options there. All right, so let's see if we can actually just put a few coordinates down here. What can we gather from this? Okay, so I see -1 is 18. We know that if x is 0, y is 6. And then if x is 1, y is 2. And then it just becomes really difficult to find because there's no integers left that we can see. Well, we've got two options. You can, as long as your step is 1, which each of these here, that's why each of these x coordinates is 1 away from the next, then you can simply take each of these y coordinates and divide it by the previous one. Watch this. So 2 divided by 6, right? So that's going to equal 1/3. Or you could do 6 divided by 18. That's also going to be 1/3. So if your x coordinates have a step of 1, you could just take each y coordinate, divide it by the previous one. That's going to be your b, or your rate. Or, if that doesn't work for you, you can just simply take this y equals 6 times b to the x, right? And let's just plug in right here. So y is 2 equals 6 times 1, and then our x is to the 1, okay? And actually that b is right there. So we're solving for this b, so we need to divide both sides by 6, right? And so we've got 2 6 or 1/3 equals b to the 1. Well, b to the 1 is simply just b, so you can just plug in an x and y. Either way you look at it, our growth rate, or in this case decay rate, since it's less than 1, is going to be 1/3, and then we just keep our x as our independent variable as the exponent. So our answer here is A.